Look at this. This code is too much. This code is too much. It's too much. So okay, here's the problem. Here's the deal. You need to check some data in a variable in Rust. Often you might use the really powerful match statement. And typically you'll usually want to do that because the match statement will make sure that you've fully exhausted all possibilities and you've covered the cases. And that's a really powerful feature of Rust. Sometimes though, you just need to grab some of the data in one of the enumerations and then move forward. And this code that we see on the screen is too much. It's ridiculous. Yeah, we've got some code comments in here. I mean, if we just look at this, ignore the code comments. We have our data. We're matching on that data, which is essentially an enum of I32. In this case, it's an option. And we match that option to capture some data because it can be some or it could be something else, right? Or nothing, right? It's either something or nothing. You can also add range checkers and branches. Really, all we want to do is capture this variable data, if there is variable data. And if there's not, we don't want to print anything, but if there is, we do. And so it's too much. It's too much code here. So we've got the solution, if let. For some use cases, when matching enums, the match keyword statement is awkward. It's awkward because there's a lot of indentation and there's a lot of code, right? You can do this much easier. Look at this right here. Isn't that much nicer? I like this a lot better. It's only 3 lines of code, including, you know, a closing syntax bracket, and it does exactly the same thing. We just want to capture data using, so it's if let sum, which basically says, if there's some data here, I want to use it. Otherwise, do nothing else. Or if you want to capture some data, if there is some, but then do something else if there's not, you can use the else statement attached to it. This right here, so much nicer than compared to this. So you don't always need to use this kind of pattern, and you often want code brevity is valuable and readability is important, especially when it's simplified like this. And so this is why they've got this if let combo. It does feel weird and unusual. This is just a Rust pattern that they've baked in that adds extra power for simplifying your code. I'm familiar with if statements and also variable bindings for assigning data to variables. Though when we look at this approach that Rust gives us, it's weird. It's unusual. If you combine an if statement together with variable binding, it is a bit confusing at first. Although it looks really clean and so here, let's take a look at the code real quick. We're gonna do a code walkthrough on this. Just taking a peek at the most critical aspect here. We have let sum I equal number. Now this kind of looks like a variable definition, right? Except for it's kind of inverted. It's like a little bit inverted because if we look at a normal declaration, we see let number, which is the variable name, equal to some value. So this sum is being put on the opposite side of the equal sign in this case. It's called destructuring in Rust. It allows you to capture the data in the variable and the number based on the data type, the struct, the enum. What's great is we can capture that data. And so there's also an if keyword here. So I'm usually used to saying if this value is greater than or equal to something, then do a thing. This is combining everything all together. So it's a nice syntax that Rust offers us. So taking a look here, we've got at our first line of code is we're defining a number that's going to be an enum with type with a number of 7. Rust comes with a couple of patterns that are really powerful, that some default enumerations. It comes with options, right? So an option data type. You can make your own, but it's nice. These are just common patterns. Like you don't need to use Rust's option. You can create your own happy option or other kind of option. It's just a pattern that Rust has implemented and they found that is really common and really useful. Another one is a result return pattern, where the result can contain the data you're looking for, which is a happy path, and the result could also return an error and information with that error. Composed and comparing that with an option return type, where the option will either have something or nothing, right? And in that pattern is what we're looking at right now is the options. So looking at line 9 here, we have let sum I is going to be essentially the variable that we're defining in this case. We're initializing this variable equal to number, which is sum, and we're destructuring it because this sum is on the other side of the equal sign, which means it's going to be equal to 7 in this case, right? So I will be 7. And then we're going to print it. Now, if I was none, or sorry, if number was none, then this would not trigger because it's not anything. It's not a sum. It's a none. So it won't trigger in that case. But when it is a sum, when there's something in there with a number, it'll evaluate to true, assign the value of the number inside to 7, which is going to be I, and it's going to print it. That's what's happening with if-let. Does this code example work? As we're looking at the screen, clearly it feels like it should work. What we're looking at is the initialization of an enumeration instance, letting a variable be defined to foobar, which is an enumeration here. Enum foo with a variant of bar. So we let a equal to bar, and then we check to see if a is foobar. But it won't work. It's so weird. It feels like that should work. I mean, is it working? No, clearly it's not. It's definitely not. It should work. The good news is you've got a couple of options. The compiler is telling you in a lot of very interesting words here. There are several options for us to fix. We can fix the problem. Now we can use an if-let, like they're describing here in this exercise, but we have to make a few syntax changes. If-let. Actually, I don't even know how this is supposed to work. We're supposed to do that, I think. I think we have to do that. I don't know. Let's see what happens. Oh, it works. Now, that's not confusing. This doesn't make any sense. So we're using the keyword let on foobar, but we're not actually defining anything. Kinda though we are, because we're creating another instance or an enumeration of foo with bar, even though there's no variable assignment or binding in terms of like a variable name like we did with this. Though we could if we added some interesting syntax. Or so be at. There we go. Wait, that'll work? Yeah, I think so. I think this will work. It looks really weird. Why does it work? What's going on? So this is the syntax that you can use to assign the at. This is basically assigning the variable, and it's checking comparison. Even though we're used to this double equals, in this scenario where we're doing an if-let, we have to use a single equal sign. Actually, I don't think double equals will work. It's going to give us an error, right? Yeah, it doesn't like that. It's like just use a single equal sign, which is counter to a lot of the cases where we're used to in other programming languages, when comparators are going to be the double equals, or right, there's the doubling up of data, of symbols, right? You've got the ampersand, the or operator, but the double equals is supposed to be the comparator. But in this case, it's an equal sign, which is usually an assignment operator. Either way, this is fairly compact, and there's really only two symbols here, other than the curly brace. There is another option. They do, so this fails, even though it looks like it should work. It totally looks like it should work. The good news is the compiler's like, I've got some options for you. You can add this annotation here, derive partial EQ, which will implement a few comparator items for this enumeration. So since bar is just a simple, it's an enum, so it's going to, under the hood, it's probably just going to be a number of some sort or an identifier. You can derive partial EQ, which will implement a trait, automatically attach it to foo. This should now compile, because now it knows through partial EQ to compare a bar with a bar. Let's see if it works. It worked! Okay. So if you really want to keep that, standard pattern syntax that we're looking for, this is another approach to do it. The at symbol, it's added again. Look, it's right there. I've been seeing this at symbol so many times. I've never used it in production code before, though it is actually pretty powerful and just very weird. I'm usually, where do you use an at symbol? Like usually when you're, say on social media, and you're at symboling at someone, right? Your at username, and then it means that you're directing that message, usually in a public form, towards a specific user. That's where the at symbol comes in. Though in Rust, they've made it an assignment essentially, it's a comparator, kind of, but it's also an assigner, sort of. All right, so here, let's walk through what we're looking at here. So we have an enumeration that's got 3 variants, and one of the variants has data that's associated, which is an unsigned 32-bit integer called quicks. Foo bar baz quicks. Okay. And we can have a comma at the end of that. Optional comma there. In case you didn't know, that should still work, I'm pretty sure. Yeah, it's happy with that. Okay. We've defined a variable c, which I'm going to bring down here so it's a little bit easier. So it's an instance of foo variant quicks with the value of 100. And what's neat with this at sign, when using the if-let, we're going to define a value, usually in this case we do something like this, to destructure the data to assign c, which is going to be this, extract the fact that it's an enumeration and only capture the value that's being assigned. So this value will be 100. However, in an if statement, you usually want to check to see, if the value is within a certain range and execute on it. So we can use the simple at operator to do check to see if exact comparison of the value here in quicks. So in the case where C's U32 is going to be 100, the value will assign and move forward and be able to print this. Now that's as close as it can get with an if-let. If you want to get more complicated with range capabilities, you can't use this add operator. You have to do some nesting. So if you wanted to check, say for example, if value greater than 100, then you could do something like this, else. So now you can do comparisons of ranges using a more complicated, more nesting. Even though the at symbol is really nice, and you could probably, I'm pretty sure this will work too. So let's make sure to bring that back up to the, actually let's delete some of this other code here. Okay. There we go. So this code will never be reached. Essentially, this is unreachable. So something we could do is say I'm pretty sure that, okay, yeah. We know it's unreachable because we have this at 100, which will only allow the code to enter the code block if C has a value of 100 inside of the enumeration. And we're checking to see if the value is over 100, which it can't be because we've done some assignment checking here with equality. It would be nice to be able to say like, you know, some syntax like that, although now we're getting a little scary looking. Though it does not let you do that. I'm pretty sure it doesn't let us do that. It's definitely not gonna work. There's no way. Rust is gonna be like, error. Yeah, see, it's not gonna do it. I wonder if range is gonna work. Wait, hold on. We might be able to get a range to work. Oh, we did, okay. So you can go beyond just exact equality and you can put a range in here. 0 to 100 with these extra fun symbols. All right, we made it even better. Okay, so now we can check to see if it's between 0 and 100, assign the value, and now we've got like some nice, concise syntax. We did have to add a few extra symbols in there, right? This dot equal sign. But now you've got a fairly compact and somewhat readable used to this particular pattern. Just in case you run into it and you read this pattern here, now you'll know what it means.